All right, number 4. So intro to concept of a limit. So we're going to see the limit as x approaches 3 of f of x. How is f of x defined? So f of x is equal to 2. So the y coordinate is 2. Every x is not equal to 3. When x is equal to 3, the y coordinate is 0. So numerically, here's our table. So no matter what x is, the y coordinate is 2, except when x is 3. It's defined as 0 per our definition right here. So as you get closer and closer and closer to 3, so as the x gets closer to 3, the y coordinate is approaching 2. The actual y coordinate of our function is 0, but for the limit is going to be 2. That's the y coordinate that it is approaching. Let's see what that looks like graphically. So as x gets closer and closer to 3, the y coordinate is 2 no matter what. Now when x is 3, the y coordinate is 0, so that's the graph. So it's open there. The limit is going to be 2. So it's not exactly where the function is at. If you go from the left, the y coordinate is 2. So as we track this way, the y coordinate is 2. As we come in from the right, the y coordinate is 2. So the limit as x approaches 3 is equal to 2. So as you get closer and closer to 3, I don't care what happens at 3, but as you get closer and closer to 3, 2.9, 2.99, 2.99999, the y coordinate is at 2. So the limit is 2, not 0 where the function has it defined. That's number 4. All right. If you have any questions on number 4, just reach out, send me an email or Google Class, and we'll discuss it further. All right, when does the limit not exist? So the limit does not exist, so we're going to use the abbreviation DNE, or does not exist, if each of the following conditions happens to be true. So f of x approaches a different number from the right as it approaches from the left. So it's approaching 2 different values. The y coordinates are going towards different numbers. Second one, it increases or decreases without bound. So basically your y is going towards infinity, or the y is going to negative infinity. 3, it oscillates. So it's like bouncing back and forth between 2 fixed values as x gets closer to c. We'll see one of each example here. All right, example 5. What's the limit? As x approaches 0 of the absolute value of x over x. If you were to plug it in, you would get 0 over 0, which again is indeterminate. Cannot determine anything from that. So if we look at the graph of it, so that's what I want to show you. I'll just put it all out. So here's the graph of it. You cannot plug in 0. If you made a table, at 0 it's undefined. There's no y value for it. So it's going to be open there, open there. If you plug in numbers from the left, so let's say we plug in 1.9999 negative on that. The y coordinate is going to be -1. So we're like right in here. If you come in from the right side, so, oh, I apologize. Let me fix this. 1.99 is not near 0. I don't know why I was thinking 2 for some reason. So plug in 0 is undefined. Plug in something just behind it, so 0.0001. Plug in something right above it. 0.001 positive. So in this case, you're going to get -1. Over here, you're going to get +1. So if you're coming from the left, tracking this way, the y coordinate is always -1. So you have -1 throughout. If you're coming from the right, the y coordinate is +1. And ones throughout. They don't agree. Since they are not equal, the limit does not exist. So if you've seen the movie Mean Girls, that is what she is referring to. Not this example, but when she says the limit does not exist, it was one of these situations, if I recall correctly. I'd have to put up the clip. But this is what she's referring to as far as limits. All right, number 6. This one, as x approaches 0, the limit does not exist because it's growing without bound. So if we made a table, so you cannot plug in 0, it's undefined there. You plug in something small, let's try 0.1, square is 0.01, you get something large. So as you plug in numbers closer and closer to 0, the y coordinates get really, really large. Similarly on the other side, it grows without bound. So it's going towards infinity. So the limit does not exist. You can use the notation infinity. Keep in mind, infinity is not a real number. But we can use that notation to discuss what's occurring here. It's telling you the function is growing without bound. So the limit does not exist. It's growing without bound. All right, number 7. The limit as x approaches 0 of sine of 1 over x. If you were to plug it in, you divide by 0, and it'd be undefined. So you cannot do direct substitution. All right, if you were to graph it, go to radians and zoom in, you're going to see that the y value is bouncing back and forth, back and forth, back and forth as you get closer and closer to 0. So it's not approaching a fixed value. It's oscillating back and forth between 1 and -1 as x gets closer to 0. If you looked at a table and a calculator, you would see that. So it's not approaching a fixed value. It's going back and forth. So once again, the limit does not exist. So those are 3 cases where it does not exist. And that is it for these notes. I will work on the next one soon and get those uploaded as soon as possible. Enjoy, ask questions as needed. Hopefully this format with YouTube is better than what I was using before. And have a good rest of your day.